Hello everyone, myself Rakshitha from Sri College of Engineering. Today's topic on data flow diagram of ARM processor. Let us see the introduction to ARM processor. Architecture, advanced RISC machines, processors are a family of reduced instruction set computing RISC architectures used in a wide range of applications from mobile devices to supercomputers. The architecture is designed to be energy efficient, making it ideal for portable devices with limited power resource. ARM processors are known for their simplicity, low power consumption, and high performance. Key features of ARM processor are Thumb 2 instruction set allows for both 16-bit and 32-bit instructions, improving code density and performance. Trust Zone technology provides hardware-based security features to protect sensitive data and applications. Neon SIMD Single Instruction Multiple Data Engine accelerates multimedia and signal processing tasks by performing multiple operations in parallel. Overview of data flow in ARM processor. During the fetch stage, the ARM processor retrieves the next instruction from memory. Next, decode. In the decode stage, the ARM processor decodes the fetched instruction and determines the operation to be performed. Execute. During the execute stage, the ARM processor performs the operation specified by the decoded instruction. Memory access. In the memory access stage, the ARM processor accesses memory if required by the executed instruction. Write back. During the write back stage, the ARM processor writes the result of the executed instruction back to the appropriate register or memory location. First, let us see fetch stage. The fetch stage is the first stage of the ARM processor where instructions are fetched from memory and prepared for execution. Steps involved in the fetch stage. Program counter PC is incremented to point to the next instruction address. The instruction address is sent to the Memory Management Unit MMU to translate the virtual address to a physical address. The physical address is then sent to the memory unit to fetch the instruction from memory. The fetched instruction is stored in the instruction register IR for decoding and execution. Next one, decode stage. The decode stage of the ARM processor is responsible for decoding instructions and preparing them for execution. This stage follows the fetch stage and precedes the execute stage. The decode stage involves the following steps. Decoding the instruction. The instruction fetched from the memory is decoded to determine the operation to be performed and the operands involved. Register file access. The decode stage accesses the register file to read the values of the registers that are used as operands in the instruction. Operand preparation. The decode stage prepares the operands for the execution stage by performing any necessary data conversions or calculations. Branch calculation. If the instruction branch is a branch instruction, the decode stage calculates the branch target address based on the branch offset and the current program counter. Control signal generation. The decode stage generates control signals that specify the operation to be performed in the execute stage and they control the data. Next one, execute stage. The execute stage of the ARM processor is responsible for executing instructions and performing calculations. It involves the following steps. Fetch instruction. In this step, the processor fetches the instruction from memory. Decode instruction. The fetched instruction is decoded to determine the operation to be performed. Perform calculation. The processor performs the necessary calculations based on the decoded instruction. Next one, store result. Memory stage. The memory stage of the ARM processor involves accessing and manipulating memory. This stage is an essential part of the processor's operation as it allows data to be stored, retrieved, and modified in the memory. In fetch data, the memory stage, the processor fetches data from memory. This data can be instructions or operands needed for the execution of the program. In store data, the processor can also store data in memory. This is useful for saving intermediate results or storing data for later use. Modify data. The memory stage also allows the modification of data. This can involve write the last stage, write back stage. The write back stage is the final stage in the ARM processor's pipeline. In this stage, the results of the executed instructions are returned back to memory or registers. Write results to memory. If the instruction has modified memory, the results are returned back to the appropriate memory location. Write results to registers. In the instruction as modified registers, return back to the appropriate registers. At last, the conclusion, clarity in data movement. The DFT provides a clear visualization of how data flows within the ARM processor architecture. This educates the pathways through which information travels, facilitating a comprehensive understanding of system operations. Identification of components. By delineating the distinct components and processes within the ARM processor, the DFT aids in identifying key elements contributing to its functionality. This segmentation allows for targeted analysis and optimization of individual components. Insight into interactions. Through the depiction of data interactions, the DFT illuminates the interdependencies among various components. Understanding these interactions is crucial for ensuring seamless communication and coordination within the processor. Thank you.